Welcome back to the AI Research Roundup. I am your host, Alex. Today we're diving into a paper called Self-Prompting Analogical Reasoning for UAV Object Detection. This work tackles a really tough problem, detecting objects and images from unmanned aerial vehicles or drones. The challenge is that these images have varying altitudes, busy backgrounds, and tiny objects. Traditional methods often struggle because they only see pixels. They don't understand the semantic relations, which are the meaningful connections between objects. This paper proposes a new method, self-prompting analogical reasoning, to help the AI reason by analogy. And for anyone looking to try this themselves, the researchers have made their code public. On their GitHub repository, you'll find the official implementation for what they call SPAR YOLO v8. The repository includes setup instructions, links to the VIS drone and UAVDT datasets, and points you directly to the main files for the implementation. Alright, so this first figure really shows the core idea in action. The top part, part A, illustrates the old way. A model extracts visual features, basically numerical patterns from the image, and builds a simple relationship graph. As you can see, it only manages to find one car. But now look at the bottom part, part B. This is their proposed self-prompting analogical reasoning method. It combines those visual features with text features, which are derived from the names of object classes, like car. These two streams interact, allowing for analogical reasoning, and the result is much better detection, finding multiple cars. Okay, so now let's look at the nuts and bolts of this architecture. The diagram is split into two main parts. On the left is the self-prompting module. This is where the magic starts. It takes in the drone image and runs it through a YOLO v8 backbone to pull out visual features. Simultaneously, it uses a text encoder to create text embeddings, which are basically numerical representations for the object class names, like car or bus. Then, a mechanism called multi-head cross-attention fuses the image and text information together, creating a special context-aware prompt that helps the model focus on important regions. So, after seeing the architecture, let's look at the practical results. This figure gives us a great visual comparison. In column A, we see the baseline YOLO v8 detector, and you can see it misses quite a few objects. But in column B, their self-prompting analogical reasoning method detects those small and dense objects much more effectively. The heat maps on the right, which visualize the model's focus, really highlight this difference. Column D shows their model's activation is far more precise and concentrated on the cars, unlike the more scattered focus of the baseline model in column C. As we've seen from those results, this self-prompting analogical reasoning method is a really clever way to boost object detection in tricky drone footage. By getting the model to think analogically, combining what it sees with what it knows from language, it can find those small, crowded objects that other models miss. This is a big step towards more robust and intelligent UAV systems. Well, that's all for this episode of the AI Research Roundup. Thanks for tuning in, and I'll see you next time.